Hi! Welcome on this video tutorial on linear algebra. Today, we are diving into a fundamental concept called scalar multiplication. Let's begin by understanding what a scalar is. A scalar is just a single number. Most of the time, it's a real number. Unlike vectors or matrices, a scalar has only magnitude. It doesn't have direction or structure. In linear algebra, scalars are used to scale other mathematical objects such as vectors and matrices. Scalar multiplications means multiplying every element of a matrix or a vector by that scalar. For example, if you have a matrix A and a scalar k, then scalar multiplication means you multiply each entry in A by k. Let's take a look at an example. Here, we have matrix A. A equals 1 and 3 on the first column, negative 2 and 4 on the second column, and our scalar k is 5. To perform scalar multiplication, we multiply each element in the matrix by 5. So, 5 times 1 is 5, 5 times 3 is 15, 5 times negative 2 is negative 10, and 5 times 4 is 20. When we pull it all together, we get the new matrix. 5a equals 5 and 15 in the first column and negative 10 and 20 on the second column. And that's how scalar multiplication works. Just multiply every element by the scalar, and you're done. Now, let's look at the first property of scalar multiplication. This property is called distributive over matrix addition. In simple terms, it means that if you have a scalar k and two matrices A and B, then multiplying the sum of A and B by k is the same as multiplying A by k and B by k separately, and then adding the results. In symbols, we write this as k times the quantity of A plus B equals to the quantity of Ka plus Kb. Let's go through an example. Suppose matrix A is 1 and 2 on the first column and 3 and 4 on the second column, while matrix B is 5 and 6 on the first column and 7 and 8 on the second column. And let's consider the scalar k is equal to 2. First, add A and B, which is 1 plus 5 is equal to 6, 2 plus 6 is equal to 8, 3 plus 7 is equal to 10, and 4 plus 8 is equal to 12. Now, multiply the result by k. So 2 times 6 and 8 on the first column, and 10 and 12 on the second column. So 2 times 6 is equal to 12, 2 times 8 is equal to 16, 2 times 10 is equal to 20, and 2 times 12 is equal to 24. Now, let's do it the other way. Multiply A and B by 2 first. 2 times A is equal to 2 and 4 on the first column and 6 and 8 on the second column. 2 times B is equal to 10 and 12 on the first column and 14 and 16 on the second column. Now, add them together. 2 plus 10 is equal to 12, 4 plus 12 is equal to 16, 6 plus 14 is equal to 20, and 8 plus 16 is equal to 24. So both methods gave the same result, showing that the property is true.
Moving on with another property, which is the distributive property over scalar addition. Let's say we've got a matrix A and two scalars k, and m. This means that when you add two scalars, k and m, and multiply the result by a matrix A, it's the same as multiplying A by each scalar separately and then adding the resulting matrices. Now, let's go through some examples to see how this property works in action. Suppose we have a matrix A containing 1 and 2 on the first row and 3 and 4 on the second row. And we also have two scalars, k is equal to 3 and m is equal to 4. Now let's apply the property to the example. Let's start with the sum of the two scalars 3 and 4, which is equal to 7, multiplied by our matrix A. Alright, let's do it with the first row. What is 7 multiplied by 1? Very good, it's 7. Let's do it with another entry. 7 times 2 is equal to 14. Moving on with the second row, 7 times 3 is equal to 21, and 7 times 4 is equal to 28. Then, our final answer is matrix A containing entries 7, 14, 21, and 28. Let's do it in the other way. Let's try to multiply scalar to our matrix A. Note, we're just going to follow the same process. We're going to do it first with the first row. So let's begin with 3 times 1, which is equal to 3. Very good. The same goes with another entry. 3 times 2 is equal to 6. Then, to the second row, 3 times 3 is equal to 9. Same goes with the other one, 3 times 4 is equal to 12. Now, we have a first matrix containing entries 3, 6, 9, and 12. Then, we're also going to the same process to the second scalar. 4 times 1 is equal to 4. 4 times 2 is equal to 8. Moving on, 4 times 3 is equal to 12, and 4 times 4 is equal to 16. Finally, we have our second matrix containing entries such as 4, 8, 12, and 16. To complete the process, we're just going to get the sum of the first and second matrices. Okay, let's add. 3 plus 4 is equal to 7. 6 plus 8 is equal to 14. 9 plus 12 is equal to 21. And 12 plus 16 is equal to 28. Then, we're done. Our final answer is a matrix A containing 7, 14, 21, and 28. As you can see, both sides of the equation give the same result. That's the distributive property over scalar addition. This property checks out. Moving on to the next, we have an associative property of scalar multiplication. In symbols, it is k times the quantity of m times a is equal to k times m times the quantity of a. This one is about grouping, just like in algebra. This property tells us how we group the scalars when multiplying a matrix doesn't change the result. So whether we multiply the matrix by one scalar first, or multiply the scalars together first and then apply them to the matrix, either way, we'll end up with the same result. Let's try this for example. Let matrix A be equal to 1 and 2 to the first row and 3 and 4 to the second row. And scalar k is equal to 2 and scalar m is equal to 5. First, let's compute k times the quantity of m times a. Start with m times a. Let's begin with the first row. 5 times 1 is equal to 5. 5 times 2 is equal to 10. 5 times 3 is equal to 15, and 5 times 4 is equal to 20. Now, multiply that result by k, which is 2. 2 times 5 is equal to 10. 2 times 10 is equal to 20. 2 times 15 is equal to 30, and 2 times 20 is equal to 40. Now, let's try the other side of the equation. The quantity of k times m times a. First, multiply the scalars, which are 2 times 5 is equal to 10. Now, apply 10 to matrix A. 10 times 1 is equal to 10. 10 times 2 is equal to 20. 10 times 3 is equal to 30. And 10 times 4 is equal to 40. Same result. That's the associative property of multiplication. No matter how you group the scalars, you get the same final matrix. Another property that I would like to introduce to you is the multiplicative identity of scalar multiplication. This property tells us that when we multiply any matrix by 1, the result is the same matrix. The number 1 is called the multiplicative identity because it doesn't change the value it multiplies. Let's take this for example. A matrix A containing an entries 2 and 2 in the first row and 3 and 3 in the second row. Now, let's supply the identity. 1 times A. 1 times 2 is equal to 2. 1 times 2 is equal to 2 as well. Then, 1 times 3 is equal to 3. Also, the other one is 3 as well. As you can see, every element in the matrix stays exactly the same. Multiplying by 1 keeps the matrix unchanged.
Now that we've covered the first 4 properties of scalar multiplication, let's look at the 5th property, called the multiplicative property of zero. This property states that multiplying any vector or matrix by the scalar 0 results in the zero matrix or zero vector. Mathematically, it looks like this. Here we have a 2 by 2 matrix A. The first row has the numbers 2 and 2, and the second row has 3 and 3. When we multiply this matrix by the scalar 0, each entry in the matrix is multiplied by 0. So, 0 times 2 is 0. 0 times 3 is 0. And this applies to all entries. Therefore, the resulting matrix is the zero matrix, where every element is 0. So, remember, the 5th property of the scalar multiplication tells us that multiplying by 0 always gives the zero vector or matrix. It's a simple but powerful rule. And now, let's recall what properties of scalar multiplication we've discussed. The first one is the associative property. This tells us that multiplying a vector by 2 scalars, one after the other, is the same as multiplying the scalars first, then applying the result to the vector. The second property is the distributive property over vector addition. This property states that a scalar times the sum of 2 vectors equals the sum of the scalar times each vector. The third property is the distributive property over scalar addition. The sum of 2 scalars times a vector equals the sum of each scalar times the vector. The fourth property is the multiplicative identity property. This property states that multiplying a vector by 1 leaves it unchanged. The last property is the multiplicative property of zero. Multiplying any vector by 0 gives the 0 vector.